Hello guys, welcome to the second session on matrices. In today's class, we're going to learn about the basic row and column operations on a matrix. I am Srinivas and we are going to spend the next 10 minutes about the basic row and column operations. Now, as a recap, in the last class, we have seen what are matrices, what are they useful for, and how do you convert a pair of equations or a set of equations into a matrix. And we see, or rather we saw in the last class, that we can solve equations using matrices. And I said that we will learn how to solve equations using matrices. But before we jump into learning about solving of equations using matrices, we need to know something about elementary row and column operations. Now, we already discussed what is the meaning of a row and a column in a matrix in the previous class. So today, let's see what are these operations I'm talking about. The first operation is interchanging of rows and columns. Let us understand what is exactly the meaning of it and how can it be done. Let us take a matrix. Let us say I have 2, 3, 5, 6, -1, 2. Right? Now, this is your row 1. This is your row 2. Whereas these are your columns. Column 1, column 2, and column 3. Now, row operation means you are interchanging row 1 with another row and you refer or you write it like this. Basically, you are interchanging, nothing else. What does it mean? It means your matrix becomes 6, -1, 2, 2, 3, 5. This is called as a row operation of interchange. So basically, you are interchanging a row with another row. Similar operation can also be carried on with a column, and that will be called as a column interchange operation. So let us say from here, if I write column 1 is interchanged with column 3, what does it mean? It means 2 and 5 will come here, -1 and 3 will remain as it is, 6 and 2 will come to the last. Effectively, this column is coming here and the first column is going to the end. This is called as a column interchange, right? So if I give you another example, if I say on a given matrix, so let us take a larger matrix, 2, -1, 3, 6, 0, 2, 5, 1, 9. And if I say there are two operations to be performed, the first operation is C1 interchange with C3. And the second operation is R2 interchange with R3. And I want the final answer. You always have to follow the order. Please do not interchange the order in which things are done. So the first thing you have to do is interchange column 1 and column 3. So you write 5, 1, 9, 6, 0, 2, 2, -1 and 3. And this becomes the first operation of column change or column interchange. The next is row 2 and row 3, which means the first row should not be touched. So write down the first row as it is now. Now third row becomes the second row and the second row will be going to the last. And this is your final answer. Okay, so this entire process is called as row and column interchange operations. This is one of the elementary row and column operations. There are actually 3 operations that you can do. This is the first. Interchanging of rows or columns is the first that we have learned. Right? Let's look at the second. Second is the multiplication of a row or a column with a non-zero number. Multiplication of a row or a column with a non-zero number. What does it mean? It means if I have a matrix 5, 6, 0, minus 1, 2, 3, and let us say you have 2, 4, 5. Now, I can take the row number 2 and write it as 3 times of row number 2. So, which means this entire row will get multiplied by the number 3. Entire row gets multiplied by the number 3. So, what will I get? 5, 6, 0. Now, minus 1 into 3 makes it minus 3. 2 into 3 makes it 6. 3 into 3 makes it 9. 2, 4, 5. This is called as a row operation with multiplication of a constant. Multiplication of a row with a constant. So this operation is called as multiplication of a row with a constant. I can do the same thing for a column also. I can take column number 3 and call it as column number 3 multiplied by 1.5. So what do I get? I get 5 minus 1, 2. First column is not touched. 6, 2 and 4. Second column is not touched. Third column, 0 into 1.5 remains 0. 3 into 1.5 makes it 4.5. 5 into 1.5 makes it 7.5. And this becomes my answer. So, multiplication of a row with a constant or multiplication of a column with a constant is possible in a matrix. So, this is a second kind of an operation. It's an elementary, basic operation. The third we are going to look after is addition of rows or columns. Now, what do I mean by this? It means, let us say I have a matrix which is 1, 2 and 5. The second row can be, let's say, 0, minus 1, 4, 3, minus 2, 6. Now, addition of a row to a row can be done, or addition of a column to a column can be done. An example being, I can write row 1 as row 1 plus row 2. I can do this and the matrix will still remain the same. What is the meaning of this? I am adding the two rows together and that answer I am putting in the place of row 1. So 1 and 0 will be added and I'll be writing 1 plus 0 is 1. 2 and minus 1 will be added. So 2 plus minus 1 is again 1. 5 plus 4 will be added. 5 plus 4 is 9. Now remember, this is only for row 1, which means row 2 will be as it is. So 0, minus 1 and 4 will remain as it is. 3, minus 2, 6 will remain as it is. This is addition of rows. I can do the same thing using columns. If I continue from here, and if I want to write column 1 is equal to column 1 plus column 3, then I can write column 1 as 1 plus 9, because these are the two columns which I'm adding. 1 plus 9 is 10, 0 plus 4 is 4, 3 plus 6 is 9. Then you have 1, minus 1 and minus 2, 9, 4 and 6. And this becomes the column addition that we have just done. This is the third common operation. third elementary operation in a matrix. Now, why are we learning these operations in a matrix? We are learning this because we will use this column operations and row operations in the subsequent classes to find answers to a few problems that you're going to come across. These are the basics or the basic operations in a matrix. Just like when you learn maths, you start with addition, you start with subtraction, you start with multiplication and a division. These are the foundation basics of a matrix. I can have another operation here. Let us say my R1, I'm going to combine two things now. R1 plus 2 times R2. So here, what am I using? I'm combining my second operation of multiplication and the third operation of addition of two rows. So what will I get? 10 plus 4 into 2. 4 into 2 is 8. So 10 plus 8 is 18. Now 1 plus 2 times of minus 1. 2 times of minus 1. That is 1 minus 2, which is minus 1, negative 1. 9 plus, remember 9 plus this 4, but 2 times of it. 2 times of 4. So 9 plus 8, 17. The other two rows will not be changed. They will remain as it is. I can do this operation also. It is a mixture of the second operation and the third operation that we have just seen. Right? So these are the three operations. Once again, interchanging of rows and columns. Second operation is multiplication of a row or a column with a non-zero number. Third is the addition of row with a column. Addition of a row with a column. Right? Now, there is a significance when it comes to row operations, especially row operations. It's very easy for you to understand. If I give you 2x plus 3y equal to 10 and x minus y equal to 7. If you convert this into a matrix, it becomes 2, 3, 10, 1, minus 1 and 7. Now, whether you write this as x minus y equal to 7 or 2x plus 3y equal to 10, the answer will not change for you, but the matrix becomes 1, minus 1, 7, 2, 3, 10. Now, why am I saying these two matrices are not going to give you different answers? Because whether you solve these two equations or you solve these two equations, the meaning is the same. So how do I get here from here? I'm getting R1 interchanged with R2, right? R1 interchanged with R2. That is not a new equation. It is the same. I'm just interchanging it. The same is not true for a column when it comes to, if I look at it from the perspective of equations. You can't say I will interchange columns and the equations will still remain the same. But row operations will keep the equations same. This is important for you to understand. So row operations does not change the nature of the equation itself. Column operations changes the nature of the equation, which means when we use matrices to solve your simple equations, we only use row operations. We do not use column operations. Column operations will be useful for other things in matrices. We don't use column operations in simple equation solving, right? Let's take another example. Let's take the second elementary operation. Row 1 written as 2 times of R1. Now I'll give you what is the meaning of this. If I say that I have two equations, let us say 2x plus 3y equal to 8, and let's say once again x minus y equal to 10. Now this becomes 2, 3, 8, 1, minus 1 and 10. These are your, or this is your matrix. Now, if I write a new pair of equations where I will multiply this by 2 and write it, right? So it is 4x plus 6y equal to 16 and x minus y equal to 10. What do I get as a matrix? I get 4, 6, 16, x minus 1, 10. Now, do you say that these two are different? They are not different. Why? Because when I multiply an equation with a constant throughout, it is not changed. So whatever answer you get for these two, the same answer you get for these two also. So that means the two matrices over here are not different at all. So how am I getting the second matrix from the first matrix? I perform R1 as 2 times of R1. That is the reason why I say the row operation can be multiplied with a constant and it will not change your matrix. However, column again does not fit this example, because when you're trying to solve linear equations, we only use row operation, not the column operation, because the analogy that I used for a row cannot be done or cannot be said for a column. Once again, we do not use column operations when we are trying to solve simple equations using matrices. We only use row operations. So where are column operations used? They will be used in finding identity matrices, in Gauss-Jordan elimination. There are processes which we will learn at a later point in time. There we use column operations, right? The last part is addition of rows and columns. Let's take a look. If I say 2x plus 3y equal to 10, x minus y equal to 5, this gives me a matrix of 2, 3, 10, 1, minus 1, 5. Okay. Now, what if I have a different pair of equations where I add these two and I get 3x plus 2y equal to 10, and I use this as it is, x minus y equal to 5. Now, whatever answer I get for x and y, the same answer I will get as x and y here also. Why? Because what I got here is nothing but the addition of these two equations, the original two equations. So when I'm not using a new equation, the answer that I'm going to get here and the answer I'm going to get here are both going to be the same. In terms of matrix, this becomes 3, 2, and by the way, small problem, this is going to be 15, not 10, it is 15, right? So 3, 2, 15, and 1, minus 1, and 5. So how do you get the second matrix from the first matrix? It is actually operation of R1 becomes R1 plus R2. When you do this, you get the second matrix, which means the first and the second actually give you the same answer when you're trying to solve simple equations. Once again, the column will not hold true. You can't do column additions when you're trying to solve simple equations. Column additions, like before, we will use it in finding inverse matrices, or we will try to use it while trying to find an identity of a matrix. Okay. So that is all for today's class, guys. In the next class, using the row operations, again, I'm telling you, for simple equations, we only use row operations. So using row operations, we will start learning how to calculate x and y from a pair of simple equations using matrices. I hope you enjoyed the class. Have a good day or a good night, depending upon what time you're watching this video. See you in the next video.